Today we're going to be starting a new series called Learn Python series. Any series that I do on Neckbeard Republic will be outside of the 1 week scope of videos that I'll be posting to the paid users. These videos will be for the general Python community, and they will generally be more towards the beginner end of the Python spectrum, dealing with understanding core concepts in the language and to eventually level up those beginners to get them up to par with the rest of the community. So in this screencast we'll be discussing the super built-in function, which is used to call and create superclasses or initialize them from other classes. I'm going to go about its uses and where it is useful and how do you go about creating them, and to actually understand the method resolution order when using super. So I've taken the opportunity to draw up a couple of classes here. We're going to just quickly go through them. We have an animal class, which subclasses object. This is what Python they call new style classes. If you see something like this, that's also a valid class. It's just considered the old type. But moving forward, any new code that you may write, you should subclass object. We have an initialization method that takes a size and sets the size on the initializes the size on the object. We also have a speak method, which has a not implemented error, since subclasses of this class will implement a speak method. So by raising not implemented error tells your reader or your implementers of your subclasses that you need to define this particular method for your subclasses. Now, being generic, animals eat all the same, so we're just going to print nom nom when the animal prints. So we need not implement that in our subclasses, and it should still work. Taking a look at the dog subclass, it has a init which takes a color and then immediately calls our superclass. Now, in order for the animal to initialize itself, for the dog to initialize itself, it needs to initialize the animal first, which takes a size, as we said earlier. So this is where the keyword args come into play. These keyword args is what we're passing back up to the superclass, so it will contain the size information that it needs for it to run. So let's just quickly run through this, but before we do that, I want to touch upon the method resolution order. Now, this is very important when understanding what's going to be actually called here. Super says call my superclass. It's very easy when there's only one particular subclass here, but in Python, which allows multiple inheritance, we could have X number of things. We could have micro here. We could have a bunch of things that this coheres to, but we need to understand which one it will call when looking up the call stack. So in order to understand that, sometimes even I get confused when using this, but this comes in very handy. So we're going to just quickly hop to a terminal. We're going to run this here. Let's call it Superman. We're going to run that. So what this MRO prints out is, and you call this on the class, not an instance of the class, this gives you all the lists of how it's going to look for things in the method resolution order. So let's say I call a method. It's first going to check the method that I'm in, which is the class that I'm in, which is dog. So it'll check to see the thing I'm asking to run, are you in dog? If so, run it. If not, go to the next one. Now, the next one in line is animal. Do you contain what I'm looking for? No. If not, okay, then go to object. And that's how the whole call stack works. Now, if I were to go ahead and define another class here, so let's go class. What can we put here? Let's just put something dumb here. We're gonna go cat. It inherits animal. It has an init. It also takes a size and accepts some keyword arguments. But all it does is print I am a cat dummy. So if we were to put cat before animal here, and run this, we would then see it would go to dog, then cat, then animal, then object. So if we were to run that and try to initialize an instance of, let's put some Pdv statements here so we can see how the invocation flow is happening. you'll see that the super, when the super is called, it won't end up going to animal, but it'll actually get caught here in cat. So let's just quickly try to create an instance of this. D is equal to dog. Dog needs a color, so we're gonna go black dog. And then we're going to go, it needs a size, we're gonna go, it's a big black dog. Go for some alliteration here, and then we're gonna go dog.speak. But that necessarily won't run because we're gonna get caught by the Pdv statement inside the cat. So we're gonna run that now real fast, and as you can see, bam, it got caught in the init of the cat. So if we go L here, you'll see on line 18 there that the super ended up resolving to the init method of the cat. So depending on your declaration of the class here, your super will do something different each time. So let's just quickly get rid of this and see that this actually does run. Remove this dumb cat class that we had from before. And let's see if this actually resolves in anything. And let's also have the dog bark, and then maybe after a while have him speak, or have him eat rather. Let's say we give him some food after he complains a little bit. And we're going to continue through that. All it did was bark because it did in fact accept the color. It did in fact accept the size, but it didn't do anything with it, and then it called bark on the subclass. So let's quickly run through here. Let's put some Pdv statements just to show you that we're actually doing the right thing here. So the first thing we should see is that it gets caught in the init here, and then it gets caught in the second init for the animal, and then it returns. We should also be able to go dog.size, or actually print dog.size, and print dog d.color. Okay, so let's go through that invocation of super. So first gets caught, it says okay, go call super, so we're gonna go next on that one. Then now we are in the initialization of the keyword args there, of the animal there. It gets caught, it returns, then we continue inside the init of animal, since it already had set its size in the super of its class. We then continue from there. We then print d.size. So you can see that I forgot to put the self here in the animal here for the eat. That's why the eat didn't run. If we just run through this again, continue, you'll see that. So you see that we were able to get the size, we were able to get the color of the dog, we were able to successfully resolve the bark call to our subclass of animal, and we were also able to get through the method resolution order to get the way the dog actually eats, which is the same as we said in our declaration for all animals. Now you'll notice an interesting thing about the way the size attribute is declared, and that is a mistake that we made during the writing of this thing. We forgot to include the double star here, which unpacks this dictionary and makes it into arguments, which is then assigned to the size here. I can touch upon this in another screencast if you're interested, but all this does, it expands out the dictionary into arguments, so it chucks the keys and just passes the arguments to this dictionary back up, which is then assigned to size, which then we assign. So if we were to run this real fast again here, we would then get the stops, for each, and then we would get big black dog that barks, and when it eats, it makes nom nom noise. So hopefully that clears up how super works in Python. When you are in doubt, use the dunder MRO on the class and print to see which way the method resolution order will happen. Be sure to unpack your keyword arguments when passing around between constructors or method calls, and be sure to make it clear to the user when you're declaring a base class that you're making absolutely clear which methods need to be implemented in the subclass and which can be left to the parent class to handle, which in our case were speak and eat respectively.